Testing. All right. So the lab was, first, take a program that asks for height in feet and inches and your weight, and then convert that into BMI, which is your weight in kilograms divided by the square of your height in meters. In order to get to this, you have to convert everything to meters and kilograms, which is not what it was before. Okay. So the first things first is to get kind of all the variables that you care about entered. So you're going to create a few variables. This is going to be feet, inches, and then pounds. Okay. And then you're going to ask for height in feet. So let me make this bigger. Okay. Inches. Okay, these are the three variables that we're going to start with and ultimately end up with converting into height in meters and then weight in kilograms. Okay, and my recommendation is first you have to convert your height in feet and inches to your height in inches. So what I'm going to do is I'm going to make a new variable that's height in inches be equal to feet times 12 plus inches. Because I know that there's 12 inches in a foot. So this is my height in inches. And then what I want to do is get my height in meters. So look at how I'm naming my variables here. It's called camel casing, where my variable names, I've capitalized the first letter of every word in my variable. So height in meters.
After the first word.
Yeah, so my first letter is lowercase, and like this just indicates it's a variable, because oftentimes when you're dealing with, so like how you capitalize and how you name things is very much like a coding standard principle that every kind of company does a different way, and this is just the way that Overwatch does it. So this is how we name our variables. So this is what we do. But I want to take my height in inches now, and I want to multiply it by this value here, 0.024254. And this thing can't be an integer because I'm doing floating point arithmetic, right? I'm doing this multiplied by an integer, so I want the result to be a floating point. Otherwise, I'm going to lose precision in here. Remember, when you're dealing with arithmetic, if all the values involved are integers, you're going to get back an integer. If at least one of them is a floating point number, you will get back a floating point number. Okay? And I can just spit out height in meters here, just as a result, just to see what that equates to and verify that what I'm doing is correct. So let me run this program here. Height in pounds. That's not correct. So my height in meters is 1.8, which seems about reasonable. And now I know that also I didn't do this. Should be weight in pounds. So I have my height in meters. And now I have to convert my weight in pounds to my weight in kilograms by dividing by 2.2. So I can make another floating point. Pounds divided by 2.2. And then the final result, which is a BMI, is equal to your weight divided by your height squared. So it says square of your height in meters. Okay. And then we can output that to the screen. I always want to know Schwarzenegger's height. He is 6'2", 249. All right. So we're gonna put in Schwarzenegger's height and weight. His BMI. 6'2", 249. His BMI is 32.0366, which I think says that he's obese. I think that's what the BMI. That's why BMI is like really, really bad, because like I think in general BMI tends to be like not representative of your overall health at all. So. $32. Yeah, he says he is obese. He's definitely way overweight, and anything over 30 BMI means obesity. So he was just hiding it. He's like what is it, Kingpin? Right? Kingpin's like looks super fat, but he's not. Right, so that's it. Any questions on this? I'll put this up on Zool. Put a copy of this up on Zool. Then I'll do the next one. Okay. All right, so the next lab was write a program that asks for the user to enter a number of seconds and then give you back days, hours, minutes, and seconds. So again, the key here is that you really want to start with a problem that you can solve that's small enough that you can understand and do one step at a time. Like trying to tackle this problem all at once gets to be really challenging, especially if you get to a really big problem. If you get to something like, I don't know, like an interview question or like a game feature or a bug that you need to fix, and you just try to start fixing it right away, it's really hard to do that, right? Like when you're baking something, you don't just start like going for the end product right away. You're mixing the pieces as you go. You start one piece at a time and you move forward, right? But that's the same idea here. Like I know what I need to get to. However, I know that I don't necessarily have to start with the full solution. So what I'm going to do is start with what I know. I'm going to call it seconds. And I asked to use symbolic constants. We're going to get to that in just a second. But symbolic constants just are a promise that those numbers are set once and never changing. And there's a specific naming convention which we're going to use for those. Okay. So once I have the number of seconds here, I want to convert that into something reasonable. So I want to start with the problem of converting this value into just minutes and then how many seconds are left over. For instance, if I know that I have 181 seconds, in my head, I know that, oh, well, that's equal to 3 minutes, because I know I can take that number, I can divide it by 60, and I get 3 as a number of minutes. But I have a remainder left over. And the remainder left over after 181 divided by 60 is there's 1 second left over. And the modulus operator will get us the result, so we can get a remainder. Okay? So if I take seconds here, I make a new variable called minutes, divided by 60. I can just do minutes and seconds left over. How do I get the amount of seconds left over from this operation here? I do the modulus of 60. This operation here will change this from 181 into 181 modulus 60. 181 modulus 60 is equal to 1, because that's the remainder of that division operation. Let's see what this looks like here. Three minutes, 1 second. We can fix that too, the pluralization. Okay. Now I know that I can get minutes out of this. However, for really big numbers, I still get 60 minutes, 1 second, which should just be 1 hour, 1 second, right? So I can do the same concept here, but I want to do the hours calculation first. divided by, now this is a division operation of how many seconds are in an hour, which is 60 seconds per minute times 60 seconds per hour. This right here is great. I mean, it works just fine. However, you know, maybe not everyone knows what this number means all the time, especially once you get to higher values. Like if I ask you how many seconds are in a decade, it gets a little bit tricky to get that, understand that that's what that value means, which is where symbolic constants come in. A symbolic constant is just a variable that says seconds per hour, which is just this. However, this value here is something that I can change later. Like I could set this equal to 42 if I wanted to, and that's totally valid, even though that's not actually correct. When you actually use a value that you want to for sure be the same no matter who uses it, you put a constant in front of it, which means that this thing will never change except for the first time you set it. And once you have something like this, the common convention is to change the naming of this variable a little bit to indicate that it's a constant. So typically you do seconds per hour, where instead of spaces you put underscores in front of it. Now that you have this, you can use this value in the equation here. And now when you're reading this equation, you see, oh, seconds divided by seconds per hour. Same exact thing. Now it's a little easier to read. Then you want to get the remainder again, which means you take that seconds per hour. You take 3600 here. Remember, this is going to be my number, 3601, if I typed it from my calculator, divided by, this ultimately returns in 3600. That's how many hours are left. Then do the same thing here, 3601 modulus 3600, which is what? This is 1. That's the remainder. So that's how many seconds are left over. Then I use that calculation down here. Okay? So watch what happens now. 3601, 0 minutes, 1 second. I haven't spit out the hours yet. Now I can do hours. Okay. Here's my hours. 1 hour, 0 minutes, 1 second. Okay. And I can repeat this for the days. So I'm actually going to do days is equal to seconds per day here. I can do that. So then my days is the number of seconds that I have inputted divided by how many seconds per day. I get the remainder of that. Then I use that variable again in the hours calculation. That's how many seconds per hour I have. Okay. That's it. These two can also be symbolic constants if you want them to. Like that. So now I have all these variables, these constants, which represent the things that I care about. If for some reason you live in a planet that has 37 seconds per minute, all the rest of these calculations are based on this value. So it'll be correct. Okay. Now if I type in 31,600,000, I get the answer 365 days, 17 hours, 46 minutes, and 40 seconds. All right. So let me put this up on Zool as well, and then we'll go on a break, and we'll come back. All right?